Thank you. Welcome to my session. And whoa, this was really quick. Okay, super excited to talk about NVIDIA GPUs and AMD GPUs in Azure for Windows versus desktop. My name is Thomas Poppelgaard, and Microsoft MVP in WVD, RDS, and a bunch of other titles. The one, of course, I want to name is the NVIDIA vGPU. So proud to be part of that in GSA and VMware UC champion, UC expert, and also, of course, part of TeamRGE. So I'm very excited and proud about that. Then I'm also Citrix CTP and CUGC for the Citrix user group in Denmark, part of the board. Let's talk about GPUs. Why do we need them? Is GPUs only for high performance? Well, so GPUs is when people say GPUs, typical business decision makers, then they think about graphic intense, Photoshop, or high-end CAD applications, or these trader workstation people down at the right with the guy with the 6 monitors. But there's also GPUs being used for other things, and it is really, really great why we have this VDI as like a pro survey that Ruben and all the other guys are running. From 2019, people submitted why GPU instances were used in VDI overall to get a better performance experience with Windows and VDI. I think it's really important. We cannot say this enough, especially also when you do cloud and Windows versus desktop, then how people are doing GPUs. Well, that would be interesting to see. It's not just for graphic intense applications, it's actually to get better use of performance. And the VDI, like a pro survey is coming out here quite soon. We can see here, still what I understand is, not super high end big monitors. So for me, that's quite interesting to see that is still evolving. But I do see that out of customers where they are actually getting more and more of these multiple 4K monitors, and many of them, and even have for some clients they actually have up to 8 monitors for one user. But the majority is still down with actually a low screen resolution to this survey. And also who use GPUs in the public, you can see, we actually have very high percentage. We don't use GPUs in public cloud. And I think this is why education needs to get better in. Why are we using them? Why are we testing them? How do we get benefits of it? Majority look actually more at cost instead of looking as a business person. How can you get people working way faster, reducing time, opening up applications? If you can reduce time, that means also people working faster. And you're actually saving humongous amount of money, but typical, that's not what an IT cost perspective, they don't look at that because that's a business level. Again, we need to talk more about this. Majority is in NVIDIA in Azure that is being popular. Again, the survey will be available at the 15th June, so let's move on. Lakeside has also made this great survey on where they have collected tons of data from different Windows 10, and they have seen how applications are consuming DirectX and OpenGL GPU applications. And they can see by each version of Windows, from Windows 7 up to Windows 10, actually the graphics intensity is really demanding and increasing a lot. And this is why we get this super fast experience when you have a GPU. If you don't have a GPU, then we do software rise and hit the CPU. Again, each time Microsoft is making new operating system, they will consume more and more graphics intense. Why? Because the stuff is providing a fast experience. Good example is browsers and other things. They also consume the GPU. So where do we start? Where do we start to understand the behavior of a typical physical machine? Physical, don't look at virtual, look at a physical machine. Why? Because in the physical machine, you have a GPU, you have averages, you have maximum values. Don't look at only averages, because the stuff that happens in peak moments are the maximum values. Those are the things you get on CPU, clock frequency, memory, how fast you see the DRAM memory, how fast you see the IOPS on the storage. Again, Ruben said earlier about how the stuff is so incredible important, these values. And again, same thing happens with GPU. And I see many people only look at averages when they go in and say, we only need this 1 GB frame buffer, but we've been peaking up at an 8 GB frame buffer. Then let's just give them a small 1 vGPU, 1 GB profiler, guys. need to look more at these maximal values, understand better what the impact will be. And if you're a good place to look at this is the task manager. So in Windows 10, and when the latest version of Windows Server 2019, you're actually capable of looking at GPU values. So it's really great to see Microsoft are getting these values inside, also with multiple GPUs in a physical laptop. They are capable of seeing both with an Intel, NVIDIA, or AMD GPU. They're capable of capturing the data. This stuff is so critical. And why? Because I've seen with some customers where they actually had laptops put out for the entire organization. And guess what? They hadn't updated their drivers. So they had these super expensive NVIDIA GPUs, but they're using the Intel GPU because it had a newer driver. And we are talking about a huge impact on an entire architect company where all the laptops, brand new, were using the low-end GPU. This is why capturing the data is so freaking critical. Real-time data is important. This is the one thing I would do first. The other step is Process Explorer, an amazing tool that's free. It's been out there for a long time. You can look at GPUs. You can go in on the view, select options, enable all the 4 GPU options, and then you can actually go in and look at usage, dedicated memory, system memory, computation. You can look at the process level, and you get an amazing amount of details. This is the tool I use, even when I educate developers, guys. People that develop stuff for GPUs, I use this tool. Amazing, right? GPUs, how do we understand them? There's so many of them out there. And it's true, and we're getting more and more of them. So the pattern is very simple. The GPU language is in compute, and then you have in memory. There are, of course, more than that, right? But if you understand these two things of the value, because how applications, when you zoom in, zoom out, pinch an application, zoom it down, minimize it, turn around an object, it can be computation. It can be decoding, encoding that happens in compute, but it can also happen when the application launches and put the stuff into memory. Each and individual things what you're doing, everything is different. This is why, how many users can I get onto this and this and this? Well, it depends on the application, how they behave. And it depends on the virtualization stack you have in. Everything depends on all the layers you add in, which impacts these values. The other things that GPUs are so important is actually these languages, what the application is doing, DirectX and all the versions you have. There's Vulkan now, which is the open library that Intel, AMD, and NVIDIA are working on. Many customers are actually working to Vulkan now because it's like an open language, that new thing. That means also you need to have GPUs that support Vulkan if you have vendors that are doing that. Now, CUDA is NVIDIA proprietary. They're developing for that. OpenCL is, again, open for all the other ones. So, and again, WebGL and OpenGL. Now, this kind of data is, again, lacking a little bit what you can actually capture here, but there are some applications where you can do that a little bit. Some of these applications, what you're going to typically do is capture the data over time, and they don't look at these values what I just talked about here. They only look at some partial information about the DirectX. But again, assessing the data from physical before you do virtual. If you don't have GPUs in virtual, it makes sense to first do it visible. Capture the data, assess it, design it. First step. Next step, browsers. How are they impacting? Well, Chromium, right? Microsoft, they gave up with developing their own. So they started using Chromium because this is really, really, most people are using Chromium, Google Chrome, you guys know. Well, the same engine behind that, Microsoft, the Edge Chromium, and that piece of software is consuming a lot of, as you can imagine, GPU consuming when you are browsing in, opening a video, opening up all the tabs and all that kind of stuff. And each application, again, here, they are behaving differently. And here it's just to give you a very good example on those 4 different applications, how they are consuming the GPU memory, or also the computation. It really can depend on what you're doing. And the things are so different. Again, when you go from different monitor and so on, different version, the things are changing all the time. Assessing all the time when you guys do software updating. This is why we need to look at the values, because they change all the time each time you do updating these pieces of software. Microsoft Teams. This one is also consuming a lot of GPU. And yeah, with the new Teams for WVD, they can, of course, go in now and offload it to the endpoint. So that's great. That's really, really great. Microsoft is doing a lot of innovation when it comes to the encoding and capabilities and the video optimization. And we have a session about Microsoft here after later. So I don't want to go too much into the things, but just want to say very shortly that Microsoft is really, really innovating, incredible in the WVD team. And it's amazing to see how many new versions of the clients are coming out all the time. And we're just seeing they are updating in a way I have never seen Microsoft in the RDS, the WVD team they've done before. And it's because the product is so getting adopted now, and Microsoft is moving incredible fast, which is benefiting us, the partners, the customers, everybody out there, because now we're getting this this client getting updating all the time. But it also means that client needs to get maintained, right? So, but again, great Microsoft are doing it. Now, single session, multi-session. This is so important. What I see most project, everybody doing like that. Multi-session Windows 10. Why? Let's save money with RDS license. Let's go away from VDI single session. Let's save money. Yeah, but hey, do your application is supported by your vendor? What impact are you getting by gaining it? Are you compliant from a license perspective, even maybe with graphics? It all depends, right? How many users can I get on with multi-session Windows 10? Microsoft are even actually pointing to putting in vGPU. So they are recommending GPU for WVD for multi-session Windows 10 to of course get a better experience and lower that. So with and without GPU, there are some places, if you look at the Microsoft documentation, they are clearly saying these version of Windows 10 and so on supports GPU. Well, that depends. So NVIDIA, they actually support also Windows 7 and 2012 or 2, but not for AMD. AMD have specific drivers for specific version of Windows 10. So it's really important that you look at the information. And I again think that the messaging needs to be more clear here. That's what I'm trying to just say here for summary. Install the right drivers in Azure. Download the drivers that Microsoft recommends. If you want to experiment, you can always download the drivers directly from the GPU vendor. So you can go ahead and do that. But I would always, of course, use the one that are recommended, updated. Microsoft updates the stuff from NVIDIA. NVIDIA having this strong relationship together with Microsoft, and they are both, updating that. Yeah. So when you go in and you spin up a machine in Azure with NVIDIA GPUs, by default, with multi-session, Windows Server or multi-session Windows 10, because the behavior is the same. It actually renders the CPU and do not use the GPU for rendering. So you actually have to go in and configure this policy for enable hardware acceleration. That's the first thing you need to do. Microsoft made some nice video the other day. Yeah, I think they are trying educating people better, but it's common seen. I've seen people don't enable these things, and also that you don't enable this session with H.264 AVC 444 graphics for and AVC hardware encoding. Enable these things, and then you're good to go and get GPU hardware acceleration. So what are the use cases? When does it make sense to use single VDI? Well, for single VDI, again, if you want to get like dedicated performance and get, again, the high clock CPU and GPU, and you get, I would say, you get more predicted performance, and you need to also make sure your applications are certified, because many applications are actually designed for, again, physical machine. This is a single VDI. You put it on multi-session Windows 10. Well, it might work, but hey, you might not be supported. So you really need to make sure you are on full support from your professional graphics ISV. So that's extremely important. Which applications are working with multi-session Windows 10? Let's just use all these products. Yeah, you're on your own risk. Autodesk doesn't support multi-system Windows 10. The different product team doesn't support it. People are doing it. Why? To save costs, but you do have a support problem. Guys, this is really, really important. I cannot say it enough. People are doing this. People are just pushing for multi-system Windows 10 without knowing actually what kind of impact you have. You are probably potentially running an unsupported state. Really bad when you got a support problem and you want to talk with the different products team then have a physical machine and you create them support ticket. That's a workaround to do that. Other use case for multi-system Windows 10. So applications, all kind of applications, I would say DirectX, OpenGL, WebGL, Vulkan, and it is really great to use multi-system Windows 10 for graphics. It can be for task users, but it can also be for super high-end graphics applications. So I cannot say enough of that. How do we then enable the graphics for Windows Virtual Desktop? So GPUs vendors in Azure, you have NVIDIA and you have AMD, and the GPU from NVIDIA, we have all these options here. So we actually have a lot of flavors, all from NVIDIA V100 GPUs, the NVIDIA P100, and M60. So you can bring in your own license. You can spin up machines. You can take in your own image. You can also take your own drivers with, your own license with you. So that means that there's a lot of way of doing that. With Azure M60, you have these kind of where you also they can spin up a machine where you actually get a license that is included. Again, there's many NV series now all over the world, and the new version, the VV3, which has a newer CPU, and again, premium storage and all that on these regions, and more coming with that. So that's great. You can also use other varieties of GPUs. So it really depends on the use case. Most I do see are the NV6 and the NVV3 being used majority out there. And those are also the recommended options for single system Windows 10. If you want to do higher other GPU instances. Oh, am I running out of time?
You've got less than a minute.
Oh man. Seriously?
Yeah.
Okay, I'm just quickly going to jump very, very quickly here. So you can do all kind of Windows operating system with these kind of instances. And with AMD, you also have the NV4. What I want to say here is this is SIOV, and it's so important. The one I recommend is the NVV8 as a minimum. Don't go down to the NVV4 because there actually are potential performance problems. I've seen where Microsoft now actually, you pay 50 cents more for the NVV16 ASV4, and then you get a higher frame buffer, and then you are capable of using all these kind of operating systems with Windows 10. You can deploy it with these kind of Nerdio. You can also use the WVD admin tool. I like using the WVD admin tool. It's one of my favorites. Guys, do assessments, use these kind of tools for like Stratosphere, UBagent Controller. And thank you. I think that was, just quickly, it was through AMD, I know, but AMD is doing an amazing work, guys. It's amazing what they're doing with SIRV. And what I understand for AMD is also we will see that in many more data centers around the world from Azure. So, and they fixed the problem. Actually, there's been a problem, with the AMD GPU.